making a ZTV study of a tower which is 100 meters tall, and we want to show with color bands the visibility of the tower in percentage wise, where you see all of the tower, where you see part of it, half of it for example, or where you see just the top of it and so on. So this is 5 times 5 kilometers area. We got the ground model made already for it, and this dot is a location where this 100 meters tall tower will be placed. So let's get to it. Go to ZTV multiprocessing, selecting the ground model, and we add the first point. It will be nearest point. Target height from ground level is 10 meters. Target description is 0.1. Distance 100, 750, and this will be 25 meter resolution for race. Now here it is. It's 10 meters height from ground. We'll use the clone to clone it. We call this next point number 2, and we change it to 20 meters off the ground. Clone 3 and 30 meters. And 100. So let's check these. Point 10 is 100 meters high, 90, 80, 70, 60, 50, 40, 30, 20, and 10. Okay, 10 points, and when you see all 10, 100%, only one, 10%. Anything between. Settings, we're going to make ZTV model. Observer height is fine, and a factor will be 10. Doesn't have to be, but now when you have 10 points visible, times 10 is 100, so the result shows 100%. It shows the visibility in percentages. Everything else fine. Let's save it. It's a good habit to save these things. We'll call it 10 points and start. We'll call this ZTV 10 points, and overwrite this report. Bring this here. This is real time. I didn't speed up the analysis. Only thing speed up was the cloning the points. That's a bit boring. Okay, it's done. So I like to do analysis on a separate drawing. Then you can save the colors and insert them to whatever base drawing you have. Anyway, let's go analyze it. Go to Z-value analysis. Select this new ZTV model. We're going to use true colors this time. We add, let's do base color something like dark red. That's always good. And now very smooth in here. Let's reverse it so darker the color is, the more you can see. Importantly, we start from 0, the bottom Z, and steps. It's so smooth because there's so many steps. Let's put only 10 steps, I think, so we can see percentage wise. I mean, Oh, let's make it smoother, why not? We'll have markers 60, any number. Let's say 57. There we go. That's that. Let's calculate it. Again, this is real time. No, speeded up on my laptop. Reasonably good laptop, but this can be done in average laptops, no problem. Okay, nice shaded red colors. Let's draw the color key and scale, let's say 50,000, probably good. Put it over there, and we can save the color key. Let's call it 1. So this shows now the colors in shades, 150 and so on. Quite nicely. You can use standard KTF crown modeling options to interpolate levels, pick points, and selecting this model. Now moving the cursor in here. On the bottom left you see Z equals 100, so 100% is visible here. How about here? 80%. How about here? 70%, and so on. There's 40%. And negative numbers mean it's not visible. So there's only 20% visible here, and so on. You can experiment with colors. I'll regenerate this with different colors just to show you. I do it when I click my fingers. So here's basically same base color, but I added hue to the lower numbers, and so decided around 75%. Let's say it's quite a lot visible, so let's make it red, and then gradually greener in the rainbow scale as you go down. And you can play with the colors, and obviously Photoshop is nice. And there's still a little bit rough gradients here, but there's only 57 separations. You can have like 128, 200. That adds a little bit to the drawing. Play with the colors as you wish, but this shows the basic principle anyway.